So here's a continuation then of the homework for Algebra 2. This is Chapter 4, Section 7. If you watched the first video, we went through number 4, 12, and 16. Number 20, maybe you noticed this about 20, maybe you didn't. I hope somebody did. 20 we had actually done in class as an example. So I'm going to kind of rush through this one. 2x squared minus 2x minus 3 in standard form. So this one we get negative 2 plus or minus square root of 2 squared minus 4 times 2 times negative 3 all over 2 times 2. So we get 2 plus or minus the square root of 4 plus 24 is going to be 28 under the square root. That's over 4. So on this one we get 2 plus or minus 2 rad 7 over 4. And on this one, this is the one where we did have to simplify. This 2, this 2, this 4 are all divisible by 2, so this becomes a 1 and a 1 and a 2. So our final answer here is 1 plus or minus the square root of 7 over 2. That one was in the notes. So if you have any questions about that, I'll gladly answer them, but that one was in the notes, so I'm not going to spend much more time on that. 24, we'll come back to that one. 28 through 36 say, evaluate the discriminant to determine how many real solutions there are, okay? So the discriminant, if you remember, is just b squared minus 4ac. So that's all you had to find. So in 28, a is negative 2, b is 1, and c is negative 28. This particular problem, everything's already in standard form, so substituting, we're going to get 1 squared minus 4 times negative 2 times negative 28 times negative 28, I said. So this is going to be 1 minus, we have 3 negatives being multiplied. That's going to be 8 times 28. Okay, this is 1 minus a lot. Now you might say, well, that's kind of cheap. Well, yeah, it is. Okay, but what 1 minus a lot's going to be, it's going to be negative something. And I don't even care what negative it is. It's negative something, which tells me that there are no real solutions, but there will be 2 imaginary solutions. Okay? So I don't even care exactly what the discriminant is. I just want to know, is it positive, is it negative, is it 0? And in this case, it's 1 minus a lot, so it's negative something. Okay? So that's 28. Number 32. Some of you are still thinking, well, what was it? Well, it really doesn't matter what it was. It's negative, okay? You don't need to know what it was. So let's see, 32. Let's try that again. 32, I can kind of tell from seeing this one that it's a perfect square trinomial, so I kind of realize that my discriminant's going to be 0, so this is going to have 1 real solution. But I'll work through it just to show you that. So b squared minus 4ac. So that's negative 12, the quantity squared, minus 4 times 1 times 36. So that's 144 minus 144, which is 0, which tells me there's 1 real solution, and it is repeated. And the reason it's repeated, if you're wondering about that, this would actually factor into x minus 6, the quantity squared, equals 0, which if you expanded it out, it's x minus 6 times x minus 6 equals 0, so we would get x equals 6 and x equals 6. So that's why it's a repeated solution, okay, because of the nature of the factoring of that. Okay, so that's 32. 36 is not in standard form, so what we need to do on 36 is to go ahead and distribute and bring the negative 3 over. So here we get 12x squared plus 12x plus 3 equals 0. You could divide out a 3 to make this a little bit easier, but you don't have to. But it would give you the same positive or negative result for the discriminant. Not the same result, but the same positive or negative result. So we get b squared minus 4ac. So that's 12 squared minus 4 times 12 times 3. So that's 144 minus 48 times 3. 50 times 3, well, let's see. Let's do it this way. 3 times 50 minus 2. That's 150 minus 6. That's, oh, 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 huh, interesting. This is 144 minus 144. So this one's also 0, which means there's one repeated solution and it's real. There's one real repeated solution, okay? Because the discriminant on 36 is also 0. Had we factored out a 4 or a 3, had we factored out a 3, right away we would have got 4x squared plus 4x plus 1 equals 0, and that's a perfect square trinomial. That would have factored into 2x plus 1, the quantity squared equals 0. So if you have a perfect square trinomial, the discriminant's going to be 0. That's kind of an interesting observation to make. Okay. Well, 40 basically is gets just kind of a summary of the notes. If b squared minus 4ac equals 0, there's one real repeated solution. If it's less than 0, there's two imaginary or no real solutions. If the discriminant is positive, there's two real solutions. Okay. So that's what they were looking for in 40. Hopefully I have enough time here to take a quick look at the bakery problem one. The one with the bagels. X is the price of bagels. They want to know the highest price the bakery can charge and make a profit of at least $200. The daily profit is Y. Y is the daily profit. So on this one, I kind of am going to do this using my graphing calculator and finding an intersection point here. What's going to happen, I'm going to get a parabola. I'm going to get a line that's going to intersect it twice, and it wants to know the highest price. So check this one out. I'm going to graph this negative 1,000. I said negative 1,000. X squared. I said x squared. Let's try this again. Clear. Negative 1,000 x squared plus 1,100 x minus 2.5. A second equation I'm going to graph is 200. Now I need to change my window. My x is how much a bagel sells for. Well, a bagel's not going to be free, and a bagel's not going to sell for more than $6, I wouldn't think. So my y min and max, I got to go clear up to 200, so I'm just going to go from 0 to 400 here, and this should give me a nice window. Okay, if I'm going up to 400, I'll probably go by steps of maybe 50 at a time. So let's graph this and see what we've got. So what I'm after are the 2 points of intersection, and in fact, it says what's the highest price that the bakery will charge. So really what I want to see here is I want to see the intersection point on the right, or the second intersection point. So what I'm going to do is I'm going to calculate this intersection point. And I have no idea where my cursor is. Well, yeah, I do. It's at 4, negative 10,000. Now it's at 3, negative 7,000. So I want to bring my cursor into view just so I can kind of see where things are happening here. As soon as I can see that, I'll be ready to rock and roll. I'm pretty close here. Maybe 1 or 2 more clicks. There we go. I'm going to go ahead and press enter twice. Actually, 3 times. So the highest price here would be 87 cents. 87 cents. It's been real. It's been fun. I'll see you next time. Have a good day. Bye.